Hello and welcome back. So last time we made sure that our players can move around, and I'm going to demonstrate that. But we have an issue which is our players can move the screen. You don't actually you can do that in Pong. So let's go ahead and fix that. Go back to our script. Let me just close the output so we have a better view here. Go back to our script. And there's a very easy way to do this. We're going to need a variable. I will write a comment here for our variables, and the variable that we will need is going to be called screen size. I mean, you can call it whatever you want, but we will store the size of our screen in this variable. Now, previously you can see that we created the right player position and left player position, and they update each frame because these values can actually change. The players are moving all the time and these values are changing all the time. The screen size, however, will never change. It will always stay the same. So really the best way to get the value of this is in the ready function. When the game starts, we get the size of the screen and we never change it. So let's go ahead and in function ready, go ahead and say screen size, and this is going to be equal to get viewport rectangle dot size. Very simple. We get this is basically the viewport rectangle, and we just get the size of this one. So it's going to be a vector 2. We're going to have an x and a y, which we can use to determine if the ball has left the screen, if the players have gone up or down and stopped their movement. Okay, now that we have the screen size, we are going to go ahead and make sure that our pads can't move out of the screen. This is done when we are about to move the pads. So in here you can see that when we're checking the right player position, we simply check if the player has pressed up, and if he did, we will move the player up. What we actually want to do is check if he can move up, and if he can, we will move him up. If not, nothing will happen. So we can actually have more statements in our if statement. So let's go ahead and say right player position dot y greater than 0. And so now we can see if the right player position dot y, so our position on the y axis, is greater than 0 and the input is actually and the up key is pressed, we will move our player up. Let's go ahead and actually check that out. And you can see I'm moving up and he stops. He stops at the half point because usually by default sprites, their collisions are kind of in the middle. This works on the center. Let's go ahead and finish this for moving down and for the other player. Very simple. Right player position dot y. This time though, we want to check if it's less than the screen size dot y. Let me just zoom out so you can have a better view here. There we go. So if the right player position dot y, so if our position on the y-axis is less than the screen size at y, and we are holding down, we will be able to move down. Again, let's also show that. So now if I'm holding down, you can see my player stops. Great. Let's do the same for the left player. Let's go ahead if left player position dot y is greater than 0 and now left player position dot y is less than the screen size dot y, and there we go. There you have it, the collision for our pads. Let's just run this now, and you can see they can't leave the screen. Great, now our game is going along very nicely. Next up, we'll make sure that the ball moves, and we'll upgrade the collision of our pads so that the ball can collide with them. Then we'll also make sure that the ball collides with the upper part of the screen and the lower part, and if it hits the left and or the right, the game restarts. We'll also add a score later. Thank you guys for watching. I'll see you in the next lecture. Goodbye. So last time we made the collision of the pads. They can't leave the screen now. If you run the game, you can see I'm moving the pads up and down and they can't leave the screen. So in this one, we're going to add the ball movement. So it's going to start moving, and when it hits the pad, it's going to bounce back. And if it hits the upper window or the lower one, it's also going to bounce off of it. Let's go ahead and open up our script. Let me just close the output here so you have a better view. The first thing, we're going to need a few variables. So let's go ahead here where we have our variable comment, add some variables. The first one is going to be pad size, because we need to have the size of our pads in order to create a collision for them. And the second one is going to be the direction of the ball. So call it ball direction or whatever you want. By default, we'll first set it to a vector 2. Vector 2s are x and y, they hold x and y values. And basically, we can set it to be either -1, which will start the ball to the left, so it will go on -x, or we can set it to be 1, and it will start on the left. It will go to the right. This doesn't really matter too much. We'll just set it as this, so you can see how it works. But later we'll make sure that it's random, so each time we play it's going to start in a different direction. Next up, we need a few constant variables. The first one is going to be for the ball speed, because we want to have a constant ball speed at the beginning. So I'm going to call it initial ball speed, and I'll set it to 100 pixels. But as well, in Pong, each time the ball bounces off a pad, the speed increases. So we have this initial ball speed, which is a constant of 100 pixels, but as soon as the ball bounces off a pad, its speed is going to increase. So we will need another variable for that. Let's create a variable called ball speed, and by default it's going to be equal to initial ball speed, to the constant. But this is going to be increasing each time we hit a pad. Now in the ready function, we want to get the size of our pad. The same thing we did, we got the screen size here, and now after that we will get the pad size. Let's go ahead and say pad size is equal to get node. Now it doesn't really matter which node you get here. You can get the left player or the right player. They're both the same size, but I'm going to get the right player. And want to get the texture and get the size of that texture. There we go. Now we have the size of our pads. This is convenient because both of these pads are the same size. If they for some reason were different size, we would have pad size 1 and pad size 2, but in this case we don't need that. Okay. Now in our update method, in the process function, we need to calculate colliders. So we will be creating them each frame as we are getting the position of the player, because they're constantly moving. Each frame they're moving, and each frame we need to get the new position. As well, with these colliders, we will each frame need to get to calculate new colliders. So let's go ahead and do that. I'm going to create a comment here and say colliders. Okay, so let's create variable left collider, and it's going to be equal to a rectangle. And now these rect2 take a vector2 position and a vector2 for size. For our position, we will want to get node. Since this is the left collider, we want to get the left player, and we want to get the position of that player, and we want to subtract this position by pad size times 0.5, and the size is going to be pad size. Now why we did this is because sprites centered their textures to the middle, so we need to subtract by size and multiply by 0.2 to get a perfect collider. Let's do the same for the right collider. Equals rectangle 2, get node, get the right player, get the position of the player, subtract it with the pad size, multiply that by 0.5, and the size is going to be pad size. There we go. Now the colliders are set up. But we also need because the ball is moving each frame, we need to get the position of the ball each frame, as well as we did for the players. So let's create a new comment here, call it ball position. And very simple, we're going to need a new variable, call it ball position. And it's going to be equal to the same thing we did with our players. We simply get the node ball and get the position of that node. Okay. So now each frame we are getting the position of the ball, but still it is not moving. So let's go ahead and get the actual movement. We can do that below this code or above. It doesn't really matter, let's do it below the player movement. So to move the ball, we're simply going to say ball position and set it to be plus equal to direction. Yeah, the ball direction, sorry. So first off, we need to know in which direction the ball is moving. Then we want to multiply that direction by the speed of the ball, and then by delta. Okay, so this will move our ball each frame. Actually, this will calculate the ball position each frame. We still haven't moved the ball. To move the ball, we do the same thing we did for the players. We get the node ball, and we set its position to be equal to ball position. There we go. But this still isn't quite done. If we run the game, you'll see the ball does in fact move, but it will just go through my player because we still we didn't do any collision checks. Let me just show you now. If we set this vector here to be -1, if we set this vector to be -1 here, and if I run the game, you'll see the ball is actually going in the left direction now. Okay, so let's now set it back to 1. There we go. And now let's back in our script. We need to check if the ball is colliding with anything. First up, let's check if it's colliding with the top and bottom boundaries. It's going to be very simple. Simply say if, and now we want to check if the ball position .y is less than 0 and the direction, the ball direction, is less than 0. So if the ball position at y is less than 0 and the direction of the ball is also less than 0, or ball position .y is greater than screen size .y and ball direction is .y is greater than 0. So if one of these two statements is true, we will simply set the direction of the ball, so the ball direction .y, to be equal to minus ball direction .y. So we will basically flip the current direction. If it was going up, it's going to be going down. If it was going down, it's going to be moving up. Okay, so that's done. Let's now do the collision checks for the pads. Very simple. Let's go ahead and say if a left collider has point, and the point that we want to check if it has is the ball position .x. Now we're checking it on the x because the pads and the ball are always going to glide on the x-axis, or right collider has point ball position dot x. So if one of these is, sorry, let's see. I'm missing a, there we go. Okay, so if one of these colliders has a point, has the ball position, has the same point as the ball position, so the same position, is considered a collision. And what we do here is a few things. So basically, we want to set the direction, the ball direction to be equal to ball direction dot x to be equal to ball direction minus ball direction dot x. So we're flipping it on the x. Basically, if it's going to the left and hits this guy, we want to flip the direction so it goes to the right. Then we want to increase the ball speed. So ball speed times equal 1.4, let's say. And we could also flip it on the y, but this lecture is getting lengthy, so let's just wrap it up here. Let's see how this looks. So if you run the game, you can see that it actually bounces off our pad and the speed does increase. So in the next lecture, we'll make sure that we create a random y direction for this. So if it bounces off, it's going to either be going up or down. So thank you for watching and stay tuned for that. I'll see you in the next lecture. Hello and welcome back. Last time what we did is we made sure that the ball can bounce off of our players, but it only bounces off in the same direction, so only on the x-axis, which is pretty boring. The game would never end. We'll fix that today. You will also notice that when the ball picks up speed, it gets to a point where it's so fast that the engine cannot calculate the collision and the ball just passes through the player. We don't want that. We have to limit that so it doesn't happen to our players. Now let's go back to our script. This is easily done. I will now close the output log so you have a better view of the script. And then in here where we increase the ball speed, we need to create a check to see if we should increase the ball speed. So what we can do is say if. Now we can compare the ball speed. If the ball speed is less than, let's say, 300 pixels, then we can increase the ball speed. So how this will work when the ball collides with the player, it's going to check, is my speed less than 300? If it is, I can increase my speed. If it isn't, I'm not going to increase my speed. So there's an easy fix. You can change this value, but don't go too high. I believe 300 pixels per frame is, I guess, good enough. Now we need to make sure that the direction, that the ball also moves on the y direction. So let's go ahead and say ball direction dot y is equal to, and we want to get a random direction. So let's go ahead and use this cool function called randef. Now this generates a number between 0 and 1, and we need to multiply that number by 2 and subtract by 1 to actually get a good direction that we need. We also need to normalize our vector. This is always done to decrease the magnitude of the vector to 1, but have the direction stay the same. So how we do that? We simply say ball direction is equal to ball direction dot normalized. There we go. Okay, so now if we run our game, you'll see now when it hits the pad, it actually bounces off, and it's also going to bounce off the screen and the top part of the screen as well. There we go. Okay, so now we need to make sure that when it leaves the screen, the game restarts. Now if I show you, if I run the game, if I just move this player away, the ball leaves the screen and nothing happens. So when things like this happen, we need to, of course, restart the game. So let's create a check to see if we, to see if we should restart the game. This is very easy to do. We just need to compare the ball position to our screen rectangle. So if ball position dot x, because it's on the x-axis, is less than 0. So let's see when does this happen. If ball position dot x is less than 0. So on the x-axis this is 0. So if the ball's x position is less than 0, that means that the ball has left the screen on the left side. We need to restart the game and reposition the ball and set the ball speed to be the initial ball speed, because we don't want the game to start off with the ball being super fast. So let's go ahead and first set the ball position to be equal to screen size times 0.5, because that's going to set it in the center where we want the ball to be. And now we also need to set the ball speed to be equal to the initial ball speed. Okay. I believe that's all we have to do. Let me just check. So now if it bounces off, if it leaves here, there we go, the game restarts. Now we have to do the same to check if the ball has left the screen on the right side. So let's check if ball position dot x. This time we gotta check if it's greater than the screen size dot x. Why? Because this is 0 here, 0 on the x, and here to the top, to the right, where you can see the angle, is the screen size dot x. So this is the maximum where we can go, and if the ball's x position is greater than the screen size dot x, that means that the ball has left the screen on the right side, and we gotta restart the game. Again, let's say ball position equals to screen size times 0.5, because we want it to be in the center, and the ball speed will also be equal to initial ball speed. Okay, let's check that out. There we go. Let's also see if the ball speed restarts. I mean, it does, but it's always, you should always check to be completely sure if it works. Let's see. There we go. You can see that the ball keeps its direction. I'm not sure if you guys want this to be this way or not, but if you don't want it to be this way, what we can do is, let's go back to the script. And here, where we change the position, we can also change the direction of the ball. Let's say ball direction. Now, I don't want it to always start from the center and just go to the right, it's really boring. What I'm going to do is I will keep the direction it was facing, but I will just change it on the x. So ball direction dot x, I will set it to be equal to minus ball direction dot x. I will do the same for this other check. So we can just copy and paste it. Now if I run, you will see. Okay, let's play. And now if this left my screen, it's going to continue and move towards him. Whereas previously, if I lost the point, the ball would still go to the left side. Now it's going, now when you lose the point, the ball goes to the winner. I guess that makes more sense. I don't know, you can do it however you like. Game development, that's the beauty of game development, you can do whatever you want. Also, another thing, we need some kind of way to keep track of who's winning. Usually we do that with scores, so let's go ahead and add a score. If you remember what we did with the rich text label when we wrote our Hello World program, and that's basically going to be the same thing now. If you're comfortable and confident in your skills, you can stop the video and go do that yourself. But if you're not confident enough, just follow along. We're going to do that right now. So right click on the world node and add a new child node. We want to add a rich text label. Create that. I will call this left score. And now I will press W to move it somewhere above the left player. And I will duplicate this and call it right score. I will also move this, press W, and move it above the right player. Okay, now we got 2 scores. Let's go back to our script. To keep track of the scores, we need some kind of variables. So let's move up. And here where we have our variables, I will create 2 more variables. I will create a left score, which is by default 0, and a right score 0. By default they're 0 because when you run the game, the scores should be set to 0 and they only increase through playing. So let's now scroll down, and here where we check if the ball has left the screen. So right now the first one, we check if the ball has left the screen on to the left. So basically that means that the right player scored. So here we increase the right score plus equal 1. We increase it by 1. You can increase it by 5 or 10, whatever you want. That's all up to you. And here we increase the left score. So left score plus equal 1. Okay, and finally, where we update the position of our players, we will also update the score of the players. And let's go ahead and, very easy, we get the nodes. We want to get the left score first, or the right, depends on you. And we want to set the text. And now this method wants a string, so it only takes in text, but we have integers here. To convert an integer to string, we simply say string, and then we open up brackets, and in here we define what integer we should convert to string. And so that's going to be left score. There we go. And let's get the node for right score. Let me just move down, and let's set the text to be equal to string right score. There we go. Okay, now let's run our game. We got a issue. Non-existent function string. I believe it's just str. Sorry about that. Now you can see we have the scores are 0, 0. And let's now score. There we go, we scored 1 point and the game just continues. Very awesome, very cool. We made our first game in Godot, Pong. It's looking really good, playing really good. If you want, you can show it to your friends, play some Pong with your friends, or add some power-ups to this game. I don't know. You can go crazy with it. You have a lot of freedom with game development, and that is why I personally love game development so much. So that's going to be it for Pong. I believe that you are now very comfortable and ready to use Godot to make a much bigger game, and we're going to be making a Mario clone. So stay tuned for that, and I thank you so much for watching, and I will see you in the next lecture.